Okay, so the second part of this question requires use of part A. So just bring your attention to what I've written in purple there. That was the answer to part A, bringing that into this question. So we're looking at this one now. So we've got a point Q lies on the curve. The tangent to the curve at Q is parallel to the y-axis. Given that the x-coordinate of Q is negative, use your answer to part A to find the coordinates of Q. Now there's an issue with this question because of the line here where it says the tangent to the curve is parallel to the y-axis. So if you consider, if we had a curve that looked a bit like this, okay, if it was parallel to the y-axis, it would actually have no gradient, okay, or in fact an undefined gradient. So in order to do this question, we're actually going to take the gradient of the normal and use that to work out the coordinates, because the normal will have a gradient. Okay, a normal to a tangent that is parallel to the y-axis will be parallel to the x-axis and thus have a gradient of 0. So let's start off, write down what our gradient of our normal is. So we'll take the negative reciprocal of our answer to part A. And that is going to be 2x plus y over x plus 2y. So as I said before, because this particular normal is parallel to the x-axis, it's going to have a gradient of 0. So we can make this equation now equal 0. And of course, to solve for this, well, we can multiply by x plus 2y. It's still going to equal 0. So it just leaves us with 2x plus y equaling 0. Rearrange that to get a value for y, and that makes y equals minus 2x. Because what that does is it now gives us something that we can substitute back into our original equation to find what that x coordinate is. Once found the x coordinate, we can then find the y coordinates. So I'm going to substitute y equals minus 2x into the original equation. Okay. So start off, x squared stays the same. Sub in minus 2x there. Sub it in there. You have that. Okay. So when we scroll back up, you can see successfully substituted x in for the y. So it's minus 2x subbing in for every time we see y. Okay, so now it just takes a little bit of tidying that up. So we have x squared, got minus 8x squared there. Be careful with this one, it is plus 4x squared there, because we're squaring it. Okay. Collect our like terms. Minus 3x squared equals minus 27. Divide by minus 3. We get x squared to equal 9, which when we take our square root, it will give us two solutions. Okay, when you get two solutions, always worth looking back at the question. And in this case, the question tells us that our x-coordinate of Q is negative. So we're going to take our negative solution and discard the positive. And once you have that, you can just substitute that back into this equation here. You can sub it back into the y equals minus 2x. So therefore, x is minus 3, y is 6, and that makes point Q minus 3, 6.